So problems on gravitation. So this is the problems on Kepler's law. The planet mass takes 1.88 years to complete one revolution around the sun. The mean distance of the Earth from the sun is, the mean distance is given 1.5 into 10 power 8 kilometer, right? Calculate the distance of the Mars from the sun. So related to Earth, what are the facts they given? So let's write it first as a data. For Earth, the time period, like to complete one revolution, it takes 1 year, right? So 1 year. And R1, I will take it as a distance from the Earth to Sun, 1.5 into 10 power 8 kilometer. So I'll convert it to meter by 1.5 into 10 power 8. Kilo means 10 power 3 into 10 power 3 meters. Next, related to Mars, we have a time period data as 1.88 years. Okay. And now we have to find the R2 value. The distance between the Mars and the Sun. So from Kepler's law, okay, see this is the problem related to the distance, okay, and the time period, right? From Kepler's law, we know that the time period is directly proportional to cube of the semi-major axis. That's what you learned, right? So that is R cube. So now take it as a T1 by T2 whole square is equal to, you can introduce some constant or you can take directly R1 by R2 whole cube. Now enter the data. T1 is 1 and T2 is 1.88. R1 1.5 into 10 power 8 and 10 power 3, 10 power 11. Divided by R2, we have to find. So the whole cube. Okay, now solve for it. 1 divided by 1.88 whole square. So we will get 0.283 from the LHS. And at the RHS, we have 1.5 into 10 power 11 whole cube. Solve that. 3.375 into 10 power 33 in the numerator. The denominator, we get R2 cube. Therefore, R2 cube becomes, let's solve for this, 3.375 into 10 power 33 whole divided by 0.283. That is equal to, by dividing these two numbers, you get 11.9258 into 10 power 33. Now take the cube root. Okay. Therefore, R2 is equal to cube root of this value. When you take the cube root, 22.8 into 10 power 10 meter, you get. So this is the distance between the Mars and the Sun. Next problem. If two spheres of equal mass with their centers 0.2 meter apart, this is the distance between the two spheres, attract each other with a force of 10 power minus 6 Newton. What should be the value of their masses? Okay, we have to find what are their masses, and both are having equal mass there, and distance between them is 0.2 meter. Okay, let's solve it. Let's write the data. So here two equal mass, so I can take m1, m2, both are as a m only, and both are separated with a distance, so that is 0.2 meter, and force between them 10 power minus 6 Newton. Okay, and also you are given the small g value and capital G value, it is given. Yeah. We can solve from Newton's law of gravitation. From Newton's law of gravitation, F is equal to G m1 into m2 by r square. So I am taking m into l since both are same. Okay, I can write it as a g m square by r square. Therefore, m square is equal to f into r square divided by g. Substitute the value, f value 10 power minus 6, r value, okay, 0.2 the whole square it is, divided by g value 6.67 into 10 power minus 11. Solve for this. So m square becomes, after solving all, yeah, do that. 0.2 whole square, I can write it as a 4 into 10 power minus 2 by shifting the point. And here 6.67 into 10 power minus 11. Right? And solve it further. 4 divided by 6.67. I'm getting 0.5997 into, this is 10 power minus 8 and plus 11. Into 10 power plus 3. So shift the 3 decimal to the right side. We get 599.7. So the meter becomes square root of that value, 599.7. So we get 24.49 kg. So this is the mass of each. Okay, both are of same mass, right? So both the masses are 24.4 kg. Here is a next problem, that if the mass of the earth is 100 times that of the moon and its diameter 5 times that of the moon, compare the weight of the body on the surface of the moon and its weight on the surface of the earth. Okay, so now which is bigger? Earth is bigger, right? Earth has 100 times mass greater than a moon, and its diameter also 5 times that of the moon. Okay, then a body, what is its weight on the moon and its weight on the earth surface? That ratio you have to find out. Let's find out that. First, write the given data. So as per the given data, mass of the earth is 100 times the mass of the moon. Okay, just I'm taking mm. It is a mass of the moon. And diameter of the earth is 5 times the diameter of the moon. Okay, so when diameter is given, you can easily convert as a radius, right? So diameter is twice the radius. This is 5 into 2 into r times the moon. Therefore, the radius also 5 times the moon. Okay, both the side after cancelling the 2 and 2. Now, we know that the formula G is equal to Gm by R square, right? We have that formula. So with respect to the earth, I can write that formula Gm divided by Re square. And with respect to the moon, so Gm divided by Rm square. Okay. So we want the ratio weight of the body on the surface of the moon to the weight of the body on the surface of the earth. Let's divide these two first. Gm by Ge I'm taking. So it becomes Gmm divided by Rm square into Re square divided by Gme square. So G and G will be cancelled out. Now I can substitute the mass and the radius there. See, I'll write as it is, and related to moon Rm also I'll write as it is into what is the Re? Re is nothing but 5 times the Rm. So it is 5 times the Rm square, right? Whole divided by Me. Me is 100 times the mass of the moon. M square. So here Gm Ge is equal to, here now here one M and one M get cancelled, here one R and here one R get cancelled, right? So here 5 square becomes 25 into Rm divided by R square both get cancelled. So here R square and R square will be cancelled. M and M will be cancelled. So now 25 divided by 100. Here is 100. So it becomes 1 divided by 4. So this is the just gravity comparison. Now for this, I can multiply and divide the masses. Okay, because we have to compare the weight, right? Since W is equal to mg, we know this to define the weight. But here in both numerator and denominator, the mass term is missing. So I will take it as a multiply and divide with the m. So the previous equation I can write as m into gm divided by m into g 1 over 4. So it becomes w em divided by we is 1 over 4. So the ratio is 1:4. Here is the next problem. A body weighs 63 Newton on the surface of the earth. What is the gravitational force on it due to the earth? Okay. At a height equal to half the radius of the earth. Okay. So we have to find its gravitational force, how much it is experiencing at a height equal to half the radius. So let us write the given thing. The weight of the body is given 63 Newton, and at a height of half the radius, we have to find the gravitational force. So that force we have to find, and radius of the earth, okay, this you must know, it is 6,400 kilometer. Okay, so this is the point where we have to find the gravitational forces above the surface of the earth. So as we all derive the expression for gravitation above the surface of the earth, okay, that formula we have to use. W is equal to mg. First you take from the weight 63 Newton it is, right? Therefore, mass of the body is 63 divided by g it becomes. Okay, 63 by g, some kg it comes. Above the surface of the earth. Above the surface of earth. Yeah, we have the formula g dash or gh you can take. Is g into r by r plus h the whole square. This is the formula to find out the acceleration due to gravity above the surface of the earth. Substitute in that. So it becomes g dash g into r divided by, what is the h? H is half the radius, right? So I can take it as a h as r by 2. So it is g, and here take the LCM. It is 2r plus r, it becomes whole divided by 2. G into 2r divided by 3r the whole square. So it is g into 4 by 9. Okay, so this is the value of g dash. Okay, that means g dash means above the surface of the earth. But the question is that we have to find the gravitational force at a height of h equals r by 2, right? Therefore, gravitational force F becomes, can take it as a m into g dash. M is 63 by g, right? Here you can see m as a 63 by g into g dash is g into 4 by 9. So here g and g will be cancelled. So solve for this. You will get 252 divided by 9. Therefore, force F is equal to 28 Newton. Next problem. Calculate the acceleration due to gravity at a point 60 kilometer above and 32 kilometer below the surface of the earth. Here it is given radius of the earth value and the small g value on the earth's surface. It is given. So we have to find the acceleration due to gravity at a height 64 kilometer above. Right? So this is the height given 64 kilometer. and the depth is given right below. Below means I can take it as a depth 32 kilometer. Okay, first let us find out the above the surface of the earth. Okay, we have the formula. Okay, you can compare here. The h is very small, right? So for h very less than compared to the radius of the earth. So we have derived the condition for the acceleration due to gravity at certain height above the surface, g into 1 minus 2h divided by r. So substitute all the values here. 1 minus 2 into h. H is 64 kilometer whole divided by radius of the earth 6400 kilometer. Solve for it. 9.8. You'll get 1 minus 0.02. Calculate the second term completely, multiply and then divide. Therefore, GH is equal to 9.8 into 0.98. That is 9.604 meter per second square. So this is the acceleration due to gravity value at a height of 64 kilometer. The next one at the depth. So I will take it as a GD, G into 1 minus the depth divided by the radius. Substitute 9.8. The depth is 32. The radius of the earth is 6400. 9.8, 1 minus 0.005 we get. Therefore, GD solve this one. We get 9.751 meter per second square. So this is the acceleration due to gravity at the depth D. Yeah. This is the next problem. Calculate the orbital velocity and period of revolution. Orbital velocity and time period we have to find of an artificial satellite of Earth moving at an altitude, okay, 200 kilometer. Altitude means at the height 200 kilometer. The radius of the Earth is given, mass of the Earth is given, and the small capital G value, universal gravitational constant value is given. So let's find out the orbital velocity first. Okay. And here h is given, right? Altitude means that is a h, height 200 kilometer it is. And the radius of the earth, mass of the earth, g value, everything is ready. Find out the orbital velocity first. So we have this formula gm divided by r plus h. So g is 6.67 into 10 power minus 11. Mass of the earth 6 into 10 power 24 whole divided by r plus h. 6400 plus the h is 200 kilometers. I'm converting into meter. Kilo means 10 power 3. Take the square root. Therefore, the orbital velocity, just multiply and calculate them. 40.02 into 10 power 13 whole divided by, so 6400 plus 200, 6600. I can write it as a 6.6 into 10 power 6. Okay, here already 10 power 3 is there. And from this also I can write 6.6 into 10 power 3. 10 power 3 into 10 power 3 become 10 power 6. Now solve it further. After solving, we get VO as a 7.787 into 10 power meter per second. Check the calculation once. The VO value 7.787 into 10 power 3. And time period of the satellite. We have to find the time period. Time period of the satellite is, use the formula, T is equal to 2 pi into R plus H whole cube divided by GM. This is the formula. Okay. So this we can write. See here GM by R plus H, the whole root, square root is called as a VO. So I can write this in terms of the VO like this, 2 pi into R plus H divided by VO. Okay. So here R plus H whole cube is there. And if you substitute this value under the square root, R plus H get cancelled, then you'll get here in terms of orbital velocity like this, the formula. Substitute here 2 into 3.142 R plus H. It's already there. R plus H. So I can use it as a 6,400 plus 200 into 10 power 3, right? Whole divided by VO value, the final result of the VO, 7.787 into 10 power 3. So I can cancel the 10 power 3 and 10 power 3, simplify it further. So we get the time period as 5322.7 seconds. So this is the time period of the satellite. We can convert into minute also. Yeah. Here, distance from the center of the Earth is 6,400 plus 36,000 it is. Okay. So this is the radius of the Earth. Here is the satellite at the distance h from the surface. Then the total distance is from the center, we measure r as a r plus h. So the total distance from the center to satellite is 4.24 into 10 power 7. Now find out the gravitational potential. V is equal to minus gm by r. Substitute all the values and simplify. You get the potential value as a minus 9.44 into 10 power 6 joule per kg. And the negative sign indicates that the satellite is bound to Earth. Means it is keep revolving with respect to Earth. Next problem. The size of the planet is same as that of the Earth and its mass is 4 times of the Earth. Find the potential energy of 2 kg mass at a height 2 meter from the planet. Now we have to find the potential energy and the radius of the planet, that means size, is same as that of the radius of the Earth, right? And mass of the planet is 4 times the mass of the Earth. We doesn't know which planet it is. Okay, so but they given in a question that mass of the planet is 4 times the mass of the Earth. Take a data like this. And a body of mass, find the potential energy of a 2 kg mass at a height 2 meter. Body of mass is 2 kg, is taken at a height of 2 meter. Okay, and the g value, you can take it roughly as a 10 meter per second square. Now find out the potential energy. We have the formula for gravitational potential energy. That is U is equal to minus G mass of the planet and to the mass of the body is divided by R plus H. Therefore, U is equal to minus G value 6.67 into 10 power minus 11. Mass of the planet 4 times the mass of the Earth, right? 4 times the ME. ME is what? Mass of the Earth. What is the mass of the Earth? 6 into 10 power 24 kgs into small m is a 2 whole divided by R plus H. So that is 6,400 kilometer is the radius of the Earth plus the height is 2 meter in addition to that. Yeah, solve for this. Therefore, U becomes minus of, solve for the numerator, 320.16 into 10 power 23. Yes, 6,400 kilometer and it's just a 2 meter difference. So very, very negotiable it is. Okay. You can see your H is very, very less than compared to the R. So while doing the calculation, you can just neglect the 2 meter. 2 is negligible. Okay. Just neglect the 2. Or you can take it like a 0.0002 into 10 power 3. Then 10 power 3 can take a common. 6,400 is 0.0002 you should write. Okay. Anyhow, 2 is negligible there. So just take it as a 6,400 into 10 power 3. Therefore, the potential energy value we get minus 50 into 10 power 7 joules.